Another sector in which stereophotography shows its true potential is that of modeling. We know very well that it is with any modeling program that the model is created in three-dimensional space and all the programs are for classic Windows: real front, side and top projection in the fourth picture in which you can see a perspective. In this case we are with the Maya program, version 6.0. The beauty of the modeling program is that it can have multiple cameras. Therefore they can model this chair and observe it, while the model, from different points of view. Clearly, with stereophotography, 2 points of view are enough for us. And, considering that, in the modeling sector, the virtual camera is quite more precise than the real one. Rather we say it is a perfect machine. We can recreate virtual rooms identical to the real ones. It seems superfluous to show the case of the 3 spheres, of the same size, taken by a single camera. Since both the camera and the 3 spheres are in the same plane, you can immediately see that one view does not say anything. You see the red central sphere, bigger or smaller, but you can't tell if it is bigger or they are all the same size, etc., etc. This example also appears superfluous, but returning to the discourse of stereophotography, just to check the true potential of the stereophoto, we take the frame of the test field of the stereometric chamber, which you have seen used to the city police in the areas affected by the earthquake. This room consists of 2 rooms with a 60mm focal length, and main distances, for the left 63.68, for the right 63.75mm. The test field is composed of 4 sites, arranged in a reference on the ground, in such a way that the left chamber is in the origin of this reference system. The first target is located 60 centimeters along the x-axis and 6 meters along the y. The second target is located 60 centimeters along the x-axis and 20 meters along the y-axis. Then we have 2 more sites on the right and on the left. Distant from the station it says meters and 10 meters. So if in the modeler we lose 4 inverted cones, and arrange them in this way, we have virtually recreated the test field. If we now project the frame of the test field to the left chamber and the corresponding frame of the same field, taken at the same time, to the right chamber, looking under the stereoscope we will have the test field in 3 dimensions. And we will realize that the 4 cones coincide perfectly on the 4 existing aims. That is, but this had to be taken for granted. Which, if there may be an error, will be that of the real metric chambers, not the virtual ones. Using this principle, we can create a virtual stereometric chamber every time, project a pair of frames taken in certain situations, remodel the objects that interest us on this 3-dimensional optical model. In this shot, you see the Cathedral of Acerenza, the area towards the altar. There are some columns and stairs rebuilt. Seen like this, with a wire, perhaps it does not make much, also because there is no stereo vision. But I assure you that, with the stereoscope, even with wire, on a reticular level, you can see everything very well. Giving a kind of fast rendering, you notice that, by moving a column, it moves, on the whole frame, respecting the perspective. So who has seen the stereo image, easily realizes that, With the stereoscope, he will see the column coming forward or backward until it is positioned at the exact point you see on the three-dimensional optical model. By remodeling all the various shooting stations and composing them into a single model, we can easily reconstruct the general model. In this other image you see a stereo pair, also from the Cathedral of Acerenza, but it concerns the backside of the church. In the degree thesis, of which you saw a three-dimensional model on the other CD, and also in this you saw a scene, the whole church was rebuilt with a series of shots made with digital camera and reassembled in this way. Now I am online. In the photogrammetric catalog you will find both the original footage of the Royal Church, and the, let's say, virtual footage, that is, the photogrammetric footage of the virtual model. This is very important, not only because, finally, of the relief, we no longer see only elevations and sections, which said little and nothing, but above all because we can remodel our monument, and foresee precisely in all the details, including color, light and everything. How would you see the monument after any restoration? This is a bit about stereophotography. We will come back again when we talk about photogrammetric shots, photogrammetric returns. However, we have seen the basic concepts on this DVD.